Something just entered our solar system, something that doesn't belong here. A faint object, gliding between the planets, moving faster than any comet we've ever tracked, and headed straight toward the inner solar system. Scientists are calling it the fourth interstellar visitor, a messenger from another star. But this one is different. Unlike Oumuamua or Borisov, this object appears alive, changing, brightening, defying every model we've used to predict its behavior. Its sudden appearance has left astronomers scrambling, not just to study it, but to understand what it even is. Because if this discovery is confirmed, it could change everything we thought we knew about space, life, and the limits of our solar neighborhood. This isn't the first time something from beyond our solar system has slipped through the darkness and entered our domain. Back in 2017, astronomers spotted a strange, cigar-shaped object speeding past the Sun. It was named Oumuamua, Hawaiian for scout or messenger. It moved too fast to be captured by the Sun's gravity, and its shape, brightness, and sudden acceleration broke every rule in the comet playbook. 2 years later, in 2019, another visitor arrived, 2I, Borisov, this time clearly a comet, with a glowing tail and familiar structure. But the message was clear: the space between stars isn't empty. It's a cosmic highway, and our solar system, just one of countless exits. Then came 3I, Atlas, detected in 2025, a 5-kilometer wide interstellar comet whose rapid brightening and strange chemical signature left scientists stunned. It seemed to defy physics itself, glowing blue near the Sun and behaving unlike anything we'd ever seen before. And just when we thought that was the last time we'd witness such a visitor in our lifetime, a new anomaly appeared, one that's even stranger, even harder to explain. The object that scientists are now calling 4I Solaris. Detected only weeks after 3I, Atlas left our view, this new body is moving faster, shining brighter, and refusing to fit into any known category. And if its trajectory holds true, it's about to make its closest approach to Earth, not millions of years from now, but within months. It started as a faint dot of light, first noticed by the Pan-STARRS Observatory in Hawaii. At first, astronomers dismissed it as background noise, a glitch in the data. But then, night after night, it moved, fast. Too fast. The Minor Planet Center confirmed it wasn't bound to the Sun's gravity. Its orbit wasn't elliptical like comets or asteroids, it was hyperbolic, the signature of something just passing through. When the data reached NASA's Jet Propulsion Laboratory, simulations revealed something astonishing. This object, now labeled 4I, Solaris, was moving at 92 kilometers per second, faster than any natural comet ever recorded. Within days, telescopes around the world, from Chile's VLT to Hubble and James Webb, turned their gaze toward the intruder. What they saw didn't make sense. It wasn't a single point of light anymore. It was flaring, pulsing in rhythm, as if something deep within was heating, cooling, or maybe communicating. Its tail extended millions of kilometers, far longer than any comet of its size should have produced. And strangest of all, spectroscopy revealed traces of elements not found in any known comet, heavy metals, and silicates laced with something reflective, something engineered. Or just unknown. For the first time since Oumuamua, scientists weren't just curious. As data poured in, the global scientific community split into two camps. One side argued it was a rare interstellar comet, formed in the chaotic birth of some distant solar system, its strange light patterns caused by volatile ices boiling off under sunlight. The other side, quieter but growing, believed something else. They pointed to the precise intervals of its light fluctuations, repeating every 47 minutes, too regular to be random. To them, this wasn't natural. It was structured. Meanwhile, NASA, ESA, and observatories in Japan began racing to collect every bit of data before Solaris vanished beyond detection range. The James Webb Space Telescope returned readings that deepened the mystery. traces of iridium and osmium, heavy elements that typically form in planetary cores, not icy comets. It's like seeing the shredded heart of a planet drifting between stars, one astrophysicist remarked. Others compared it to Oumuamua's non-gravitational acceleration, suggesting outgassing, yet Solaris showed no visible jets, no fragmentation, no heat signatures where it should have been venting gas. Whatever was propelling it wasn't ordinary physics. And then came the image that froze every scientist in silence, a high-resolution composite showing that Solaris wasn't smooth or spherical, but hexagonal. 6 clear sides, almost symmetrical, like a fragment of something far larger, or something designed. They were nervous. Publicly, agencies called for caution. Privately, emails leaked, showing that top researchers were terrified. Because Solaris wasn't just passing through the solar system, it was slowing down. At first, the deceleration was subtle, just a few meters per second. But as Solaris neared the orbit of Mars, the data became undeniable. It was changing trajectory. Natural bodies don't do that. There were no visible jets, no gravitational encounters that could explain the shift. Yet every day, the object's course adjusted, fractionally, precisely, as if responding to something unseen. Some theorists called it a solar sail effect, but that required materials with reflectivity far beyond any known substance. Others proposed magnetic propulsion, but the readings didn't match any natural signature. Then, a new anomaly appeared. Radio telescopes in Australia detected a faint repeating pulse, low frequency, structured, perfectly timed with Solaris's light fluctuations. At first, it was dismissed as background interference, until 3 other observatories confirmed it. A pattern. A rhythm. Some said it was cosmic coincidence, radiation patterns amplified by rotation. Others whispered the word signal. What if Solaris wasn't just a rock or an ice ball? What if it was a probe, drifting for eons between stars, only now awakening under our sun's light? Whatever Solaris is, it's doing something no comet, no asteroid, and no natural body should be capable of. It is, by every scientific measure we know, impossible. If Solaris truly is what the data suggests, then we're standing on the edge of one of the greatest discoveries in human history. Because this isn't just about a new comet or a wandering fragment. It's about contact, in its purest, quietest form. A messenger from somewhere beyond our star, carrying chemistry, structure, and motion that don't belong to us. Some scientists believe Solaris could be a relic of an ancient civilization, a dormant probe launched thousands, maybe millions of years ago, now reactivated by the heat of our sun. Others see it as a natural artifact, a cosmic fossil forged in the violent collapse of an alien planet, a shard of history flung across the stars. Either way, it changes us. If it's artificial, we're not alone. If it's natural, then the universe is far stranger and more creative than we ever imagined. What's more, Solaris is teaching us. Every reflection, every emission line, every pulse of light it sends is data, information from another world's chemistry, another system's birth. It's a bridge between stars, between civilizations, between eras of understanding. But as it draws closer to the sun, its signals grow weaker. Soon, it will vanish, lost again into the endless dark between the stars. And we'll be left with only questions, and a new awareness that maybe, just maybe, the universe is watching back. And just like that, the visitor is leaving. Its brief journey through our solar system has ended, a silent traveler returning to the endless night between the stars. We've recorded its path, studied its light, measured its secrets, yet somehow, it still feels like it left us with more mystery than it brought. Maybe that's the point. Every once in a while, the universe sends a reminder that beyond our orbit, beyond our noise and our small blue world, there are stories still unfolding in the dark. Solaris may never return, but it will be remembered as a mirror held up to our own curiosity, our fear, our wonder. Because in chasing it, we learned more about ourselves than about the object itself. The night sky is vast. Somewhere out there, another traveler may already be on its way, drifting silently toward us across the void. And when it comes, we'll look up again and ask the same question we always do: who or what is really out there?